So hello everyone, hope you're doing good and welcome back to my channel. Today we are at the second day of the June daily Leetcode challenge, and we again have a medium level question in front of us. Okay, see, basically this kind of questions you would have seen previously. Also, we have solved this kind of questions, but this time we will have a very interesting approach. Like the question will look very different. It will look like a mathematical problem. It will like you will think it can be solved in a mathematical approach, but finally we'll realize that we are this data structure actually it's an application of that. Okay, what it is and how to see this kind of question will be really helpful for you because when you see the question you will have different thoughts in your mind, but ultimately when you realize that all possible solutions are based on a particular data structure. Okay, let us see what the question is. It's question 2101. Detonate the maximum bombs. Okay, detonate means explode. Okay, it's a like synonym of explode. Explode the maximum possible bombs. Okay, so what the question, first let us see what the input given is. You can see something that is called bombs. Okay, it's the name of a list. You can call it a 2D list because inside it there is one more list. Okay, so these are the things given to us. You clearly see the each element. Okay, here is a list. Basically it will have three elements. Okay, what are those, the what meaning they convey, let us see in the question. Okay, so we can clearly see we are given a list of bombs. Okay, the range of a bomb is defined as the area where its effect can be felt. Okay, the area is in the shape of a circle with the what that means is, if, for example, if you have a bomb in this particular dot. Okay, so it can explode in this particular area. Okay, the purple or violet, whatever you call it, the color which you're seeing here. Okay, so basically in technical terms we call it as a blast radius. Okay, if you have a bomb at the center, its impact can be felt along its blast radius. Okay, so if a blast radius means the distance. Okay, so if you see it's like in form of circle, if you see the total area, right, that is the basic idea of it. Okay, so yeah, the bombs are represented okay by a zero index to the array of bombs where bombs. So that's the seam. Now they are giving the meaning of each of the terms. Okay, so what are three things which you are seeing here? See, for example, each thing here has three integers. Okay, what are the meaning of that? See, first one is the the x component of it. That means the x index, then the y index, and then the radius of it. Okay, bomb radius. Okay, xi and yi okay denote the x coordinate and the y coordinate of the location in which the bomb is present, right? Of the earth bomb, and the ri detonate, like it represents the blast radius of it. Okay, blast radius. Now this is all about how the question is given to us, but what we have to do is still not mentioned, right? So they have mentioned here, you may choose to detonate a single bomb. Okay, when a bomb detonates, it will detonate all the bombs that lie in its range. Okay, what that means, for example, see, if you detonate this violet bomb. Okay, so you can see the green bomb is also at its circumference. Okay, that means it's within its radius. Okay, so if you detonate this bomb, the green bomb will also detonate. That is the basic idea. Okay, you may choose to detonate a single bomb. When a bomb detonates, it will detonate all the bombs that lie in its range. Okay, these bombs will further detonate the bombs that lie in their range. Please see, this is the most important part of this question. If you do not understand this, it will be very difficult for you to decide which data structure to choose to solve this question. Okay, I will again repeat. You may choose to detonate a single bomb. Okay, you will start by exploding a single bomb manually, but after that, it will be everything will be happening automatically. Okay, how it is? See, when a bomb explodes, or okay, it will explode all bombs that lie in its range. Okay, for example, suppose in this violet region there is one more bomb. Okay, that will be also exploded. Okay, and it will keep happening like that. Okay, for example, the bombs that will further detonate, that will further explode, the bombs that lie in their ranges. Okay, that is the basic idea. If we see some examples here, yeah, mm, yeah, this example you can see. For example, see this, if I detonate the red color bomb. Okay, so you can see its radius here. Okay, so you can see the blue color bomb is also in its radius. Okay, please pay attention here. These things, see, the more faster you understand the question, the better it will be. The faster it will be for you to decide which data structure to take. Okay, please pay attention here. There are three circles here. Okay, uh, there are three circles here: the red circle, the blue circle, and the green circle. Okay, this represents the radius of the center of the red circle where the bomb is placed. This represents the center of the blue circle where the bomb is placed. This represents the center of the green circle where the bomb is placed. Okay, I am starting with zero. Okay, and that means the red circle. I am detonating it. Okay, I am exploding it. What will happen is, see, the center of the blue circle is in its blast radius. So this will also explode. Okay, now since it is exploding, so this particular region which is seeing here, that is outside this red circle, but it is within the blue circle. Okay, that region also will be affected. That means the green bomb, okay, its center is within the blast radius of the blue one, okay, so it will also explode ultimately, okay. So the idea is, if I explode blue, it will lead to explosion of the if I explode red, it will lead to explosion of the blue, which will further lead to the explosion of the green. Okay, that is the basic idea. My advice to you will be, if you are not understanding, please pause the video, like play it slowly. Okay, read the question once, play it slowly, and you also have option of like pause, returning back and playing the video. Can right? You can also rewind and play the video. See, I'm trying to cover as many points as possible, but I may be going a bit faster, right? But I am sure if you see the example, if you see the question once again, you will definitely understand. I am always giving the question link in the description. Okay. Now, next thing is, see, this part we have made it very clear now. Okay, this particular part. Yeah. Now come to the question. Given the list of bombs, return the maximum number of bombs that can be exploded if you are allowed to detonate only one bomb. What it means is, see, we are given these many bombs. Okay. Here in this case, two bombs. Here in this case, some five bombs. Okay. In out of this, I am only allowed to explode one bomb. Okay. I am only allowed to explode one bomb, which should then the question is, one bomb. Okay, return the maximum number of bombs that can be exploded if we are allowed to detonate only one bomb. Okay, so I will explode one bomb. It will lead to explosions of other bombs within its blast radius. Like that, how many maximum blasts we can do? That is the question. Okay, so let me tell you this very briefly. I am going to use the graph data structure for storing it. Okay, so what I will do is, for example, uh, yeah, in this case, as you can see, the blast of this, okay, red will lead to blast of blue, so I will store them as a graph. Okay, that means for this node I will create a directed edge towards the blue node. Okay, so what I mean to say is like this. Okay, if you see here, yeah, you can clearly see the blast of the blue will lead to blast of the green. Okay, that means in terms of graph, I will store it. See, this node, I will make a pointer edge to green. Okay, like I will make an edge. Okay, directed edge to green. I will store them as a graph. That means, for example, A is connected to B means the explosion of A will lead to the explosion of B. That is the basic idea. And how I will be deciding that, it will be based on the equivalent distance. Okay, so finally, it will look something like this. Okay, after I have converted, see, for example, if I explore the first node, it will lead to explosion of two node and the explosion of node four. Okay. Similarly, if I explore the fifth node, it will lead to explosion of three. It will lead to explosion of two. It will lead to explosion of four. Okay. So one thing, please make it very clear. Okay, one is directed towards two. That means the explosion of one will explode two, but two is not directed towards one. That means the explosion of two will not explode one. Please make this point very clear. That means, okay, one ij and j and I, they both are different here. Okay, what that means is, see, if I have edge towards one and one from one to two, okay, from one edge is there towards two. That means the explosion of node one will explode node two. But the reverse is not true. Okay, the explosion of node two will not explode node one. Please make this point very clear, because in this question, see, we are going to use direct edges. Okay, these are not undirected ones. We are going to use strictly direct edges. Okay, so one thing is very clear now. If bomb one explodes bomb two, then there will be directed edge from bomb one towards bomb two. Okay, please make this point very clear now. Now we are good to go with the question. Okay, I don't need any other help from the text given here. I can directly go for solving the question. Okay, I am creating this thing is very clear. We'll show the given data in terms of a graph data structure. Okay, now, for showing the graph, I'll be using a dictionary. Python dictionary means basically a mapping. Okay, a mapping of a key with its value. Okay, that is what is a graph. Dictionary in Python. Okay. Now I will be taking the number of see length of bombs. Okay, bombs is an array basically. So n basically represents the number of bombs given to me. Okay. So I will be traversing this in two times. Okay, like in an n square approach. Okay. What that means is, see, ultimately, I have to find for each bomb, okay, for each ith bomb, if it detonates the ith bomb or not. Okay, so I am starting two for loops in the same graph. Okay, in the same bombs array. Please pay attention here. See, for both things, you can see the range is same. Okay, it will also run in the range n 0 to n. It will also run in the range 0 to n minus 1. Okay, so both of them is same. Okay, so the idea here is, for every I am trying to find out how many bombs it can explode. Okay, that is the basic idea. Okay, if I and j are same, just continue, because a same bomb will explode itself. That is obviously true. So we need not consider it. What I'm doing is, for the first bomb, These are the parameters. Okay, x and y represent its x and y coordinates. Okay, RA represents blast radius. Okay, similarly for the jth bomb. Okay, xj and yj represent its x and y component, and we do not want its radius. Okay, see here when I say I and j, I want to check if ith bomb can explode jth bomb or not. Okay, the reverse I am not checking correctly. Okay, I am not going to check the reverse for now. Okay, so here I am only going to check if the ith bomb can explode jth bomb or not. That's why I don't need the radius for the jth bomb. Okay, but I need the radius for the ith bomb. Okay, so now I'm going to check if my, see, this is the excluding distance. See what is excluding distance? See, x square plus y square. Okay, now suppose I'm given xi yi, similarly xj yj. How to find the distance between the two? This is the formula. Okay, this is pure maths. Okay, it's called including distance. You can just Google it once. You'll get the formulas. Okay, xj minus xi whole square. Okay, this star star was seeing, it refers to square. Okay, so xj minus xi whole square. Okay, plus yj minus yi whole square. Okay, so this will give me the equivalent distance. Okay, now I am going to check if this distance is less than or equal to the radius square or not. Okay, the square of the blast radius or not. If it is less than that, that means my ith bomb will explode the jth bomb. Okay, that is the basic idea. If this is true, okay, if this whole condition is true, that means the radius between the two bombs, that means the radius between the center of the two bombs is less than the blast radius of the first bomb. Okay, then that means the jth bomb will explode if I explode the ith bomb. Okay, that is the basic idea. So what I will do is, if see, this is basically how we fill the graph. Okay, so if I is in the graph, then see, basically this is how I will start. Okay, if I'm going to see, if I is not present in graph, this will be executed. What it means is, for graph of I will create a new list. Okay, in the list, the first element I will include is j. Okay, if the list is already existing, then I will just append j in that. Okay, that is the basic idea here. Okay, so that means for the ith node, when I say, I will be having all the nodes in this particular list, which will be blasted if I blast I. Okay, that is the basic idea. Okay, I will just quickly print and show you how it looks, so that you will have a better understanding of how it works. We'll directly go to the third example, because that is a more comprehensive example, a better example. Okay, so here you can see, if I the zeroth bomb is blasted, it will blast one and second bomb. Okay, similarly, if the second bomb is blasted, it will lead to blast of first and third bomb. Okay, and so on. Okay, if the third bomb is blasted, it will lead to blast of 1, 2, and 4, and so on. Okay, something will there will be so much data. Okay, so that is the basic idea. This is how the graph will look. Okay, now coming to BFS. So my idea, see, in this case, we have to individually check for each bomb. See, because if you see the questions they have clearly given the list of bombs, return the maximum number of bombs that you can detonate if you allowed to detonate only one bomb. So this one bomb, which bomb it will be? Okay, we don't know, right? For that, we have to, what the idea here is, I will start a BFS from each node separately. Okay. For example, there are 5 nodes, so I will start a separate BFS for each node separately. The BFS will, from that BFS, we are going to understand how many bombs that will be blasted if I, start with that particular node. Okay. What that means is, see, this is my BFS function. Okay. Please pay attention here. If I start with this particular node, okay. If I start with this particular node, okay, how many bombs will be blasted? Okay, let's try to understand how it will happen. Okay, so this is a simple BFS, so you will understand that there will be queue. Definitely in the queue, the first element will be node itself. I have a visited set. Okay, the first element will be node itself again. Okay, because it's already visited. While this queue is not empty, this loop will run. Okay, I am popping out the leftmost element. I will call it as I. Okay, if I is in graph, if it's not in graph, we can't do anything. Okay, if it's in graph, if it's graph, means there will be definitely some other nodes which will be impacted if this particular bomb is blasted. Okay, that then we'll go to those nodes which will be blasted if I blast the bomb I. Okay, so J will represent all those nodes which will be blasted if there is explosion in bomb I. Okay, so I will just check if J is not in the visited. That means if J is not already exploded, I will just add it in my visited J, and I will again add it in my queue also. Okay. This whole thing is just a simple BFS. It's not related to this question. Basically, it's just a BFS algorithm, okay, which we are implementing. But one thing you will understand is that this visited set at the end of this, like once we do the whole BFS algorithm, all the BFS traversal, this visited set will have all those nodes, which will be impacted when I blast the particular node. Okay, this particular node. Okay, so the length of the visited node will tell me how many bombs will be blasted if I start with blasting this particular node. Okay, so we will run this algorithm for all the nodes. Okay, for each node. We'll run this algorithm, and the return will be the number of nodes that will be impacted if I blast this. Okay. See, this is what is meant by this. Okay. This one bomb, which this is what we are basically going to see. Which bomb is going to give us the maximum number of blasts? Okay. That is really returned. Okay. So this variable I'm creating. Okay. Maximum blocks detonated. Initially, I will initialize with 0. Okay. And now I will be going through each of the nodes again. Okay. Each of the bombs again. Okay. These are the bombs. Okay. I'm going through each of those bombs again. Okay. I will start a BFS traversal from it. Okay. This is what I'm calling BFS of Y. It will return me the number of bombs it is going to blast. Okay. So it will return me the number of bombs that will be blasted if I start blasting the ith bomb. Okay. So it will return something. Okay. Let's say it will return 5. Okay. This is 0 initially. This thing is 0 initially. It will return 5, which is max of 0 and 5. 5 is the maximum. That will be stored in this. Okay. You can see this and this are same, right? So idea is whatever is the maximum that will be stored here. Okay. The maximum number of the blasts that can happen will be stored in this particular variable, and finally we'll return this variable. And here it's optimization. You can, if you want, you can delete it. It will work the same way. The answer will be accepted, but this is optimization. Okay. You can understand that at a maximum, the bomb number of bombs which are going to blast is going to n, right? More than that, obviously we can't do. So if I find that number of bombs being returned is n, that means that is the maximum. We will return directly. We are not going to do the BFS of the remaining nodes. Okay, that is the basic idea here. Okay. So friends, please understand this part. See, here we are going to trying to make the graph. Okay, here we are trying to do the BFS for each of the nodes. Why for each of the nodes? Because see, in the question they have not given any one node from which we need to start the, the blasting. Okay, they have just given a hint. Okay, they are just giving the hint like this. Okay, we need to blast any one node, and then we need to find the maximum number of nodes that will be blasted if we start with this node. That is the basic idea here, friends, and that's what we are doing. I'm creating separate variables to store the number of maximum that can be blasted for any one node's blast. Okay, and finally I'm iterating. See, I'm going to do a BFS for each of the nodes, and it will return me the number of nodes which will lead to. For example, if I start with the ith node, if I start with blasting the ith node, how many more bombs it can blast? It can lead to the blast of how many more bombs? Okay, that's what I am doing here. And finally, it will be stored in this particular variable. And finally, this variable will be returned. This will be the final answer. If I can quickly run and show you. So basically, yeah, this is how see. I will just print and show you how the BFS of 0 works. Just let us see. So I will go to the third example because it's a more comprehensive example. So please try to understand here, friends. If you can see the example here, see, if you blast the zeroth node, you can see that all the nodes will be blasted. Okay, that is what is the STD out. Okay, you can clearly see here. That's what is V so 0 getting printed. Okay, so yeah, other than that, also if I can run and show you. So yeah, you can see all the stresses are getting accepted. And one more thing, let me quickly show you the how much. See, this solution beats nearly 91%, or you can say nearly 92% of the solutions. Okay, this is really fast. Okay, and we are using BFS approach here. This question can also be solved in DFS, but we are using BFS here. Try to understand one thing here, friends. The time complexity here is really high. Okay, it's nearly O of n cube. Why you now you will ask me why of O of n cube? Let us individually see the time complexity which of these. See, here two for loops are being used. See, whenever we talk of generally BFS solution, okay, it's the time complexity going to be O of V plus E. Okay, V is the number of nodes, you can say. E is the number of edges. Okay. So yeah, we'll go one by one. So in this, for making the graph, the time complexity is going to be O of n square. Okay, O of n square for this particular part. For making the graph. Okay, yeah. Next comes the BFS. Okay, for BFS we already know the time complexity of V plus E. Okay, but see, you have to analyze the worst case. Okay, so O of V plus E in this case, please try to understand. See, for each node n, see, for each node there can be n minus 1 edges, right? So for n nodes, how many edges are there? So n into n minus 1, which is almost of O of n square, right? O of n square, right? So BFS will be almost of O of n square for us. And but remember, we are going to the BFS for each node. So O of n square for each node. That means O of n square for n nodes. That means almost O of n cube time complexity is coming. Okay. And if you ask me how much space complexity, it will be around O of n square, because we are generating a new graph data structure, right? Graph can be stored in adjacency list, which you can say O of n square, right? In the worst case. In this case, we are using a distance to store it. But in the worst case, for each node, there will be n minus 1 node connected to it. Okay. So yeah, you can say it will be around O of n square. So and the this is space complexity, and the time complexity, as I mentioned, it will be O of n cube. Why O of n cube? Because see, the BFS will have O of V plus C. Okay, the vertices plus the number of edges. In this case, if you calculate the number of edges, it will be around. See, for each node, it will be around n minus one edges in the worst case. Okay, so how many nodes are there? N nodes are there. N into n minus one, it will be around O of n square. Okay, so the BFS itself will be for O of n square. Okay, but we are going to do the BFS for each node. So for n nodes, we are going to do, see, for the one node it is of n square. For n nodes, how much it will be? So it will be obviously of n cube time constant. Okay. So yeah, friend, that was all for today. If you have tried in the DFS approach, please do comment below. Let us discuss further from that. But I feel BFS will be more, understandable, more imaginable. That's what I felt. That's why I tried with BFS. So yeah, friend, that was all for today. If you have any doubts, please do comment below. Thanks a lot. See you tomorrow.